Okay. It's wonderful, wonderful to hear about that work. So it's 9 o'clock, and I'd like to welcome folks who are tuning in for our second talk during this current research section. So I'd like to invite Tom Beauvais and Lisa Burns to share their screen and get their presentation fired up. Welcome, you two.
Morning. Thanks for
Good
having
morning.
us.
Absolutely. Thanks, you guys. Tom Beauvais, Lisa Burns, they are going to be speaking to us this morning about Burnett and Washburn County's efforts to gather new data related to zebra mussel suitability. And this work, they hope, will help us better prioritize zebra mussel prevention efforts. So without further ado, take it away, folks.
Yeah, so thanks, Allie. That was a good introduction. This is Tom Beauvais speaking. I unfortunately do not have a camera, so I apologize. You won't be able to see my beautiful face, but I see Lisa has hers, so you can focus on her. But anyways, yeah, we're going to talk a little bit today about the Smart Prevention Tool, the AIS Smart Prevention Tool. And if you're not familiar with it, this title screen here kind of has a little picture of what it looks like. And we'll get into a little bit more detail, but it essentially prioritizes lakes based on their suitability to certain species. And we are focused on zebra mussels because we do have some in our area here, and we'll talk a little bit more about it.
All right. Well, good morning. Lisa Burns with Washburn County Land and Water Department. So I'm just going to kind of do a quick background of this project. So in 2016, zebra mussels were found in Big Mackenzie up here in the north. And a year later, they were found in Middle Mackenzie. So Big Mackenzie is actually split between Burnett and Washburn counties. So with that, we thought, talking with Burnett, we thought, well, let's get a grant together. So we applied for a rapid response grant to do some monitoring and prevention efforts. And through this, we had a lot of different partners and still continue to have a lot of partners, including our Washburn and Burnett County Lakes and Rivers groups, Fish and Wildlife Service, Wisconsin DNR, and many, many individual lake associations are helping, and lake association individuals. So thank you to all of them for helping out with that. And I'm pretty sure there's a couple of them on this presentation today. So over time, this AIS Smart Prevention tool came out and started to get discussed more. And one of the big questions that a lot of our lake groups were asking is, what is the actual calcium in my lake? So again, we use some of this funding to do some of this research. Next slide. So what is the AIS Smart Prevention Tool? So it's basically a tool that was developed by the Center for Limnology in partnership with Wisconsin DNR. Which is a model that provides predicted suitability for 6 high-profile invasive species. So zebra mussels, of course, is one of them that people are interested, but there are 5 other species that are also showing up on the map that you can look at. So a lot of this data, in this case, conductivity, was gathered from a lot of old limnological studies, but a lot of it came from the Surface Water Resource Inventory between 1960 and 1980, which was carried out by the Wisconsin DNR and other agencies. So on the bottom of this slide is the link to get to the tool. So if you're interested, you should try to visit that site. You can bring up your lakes or your county or the area that you're interested in and see what different species, what they need for suitability to survive in a water body. Next.
And I'll mention one more thing about the smart prevention tool. It does have a disclaimer on it that a lot of the data that you see on the slide is not field verified. So this was one kind of little snapshot, I guess, of us trying to field verify some of our lakes here in Burnett and Washburn counties.
So again, through the grant, we had a little bit of money left over last year, and we're like, well, let's try to get this amended. So we did have to do a scope amendment with the DNR, and they thought this was a great idea. So with the amount of money that we had enough for 30 lakes. So we split 15 lakes per county, and we chose those lakes based on how close they were to the Mackenzie chain. So there's actually another Mackenzie lake. So there's 3 of them. There's Big, Middle, and Lower Mackenzie. So we based it off of the proximity to those lakes, how involved lake associations are around our counties, and then of course the amount of pressure, recreation, traffic, and then suitability. And to get kind of a good baseline and work with different outcomes, we did want to do we wanted to have a variety of predicted suitability to work with. Next.
So now we can get into how the model defines zebra mussel suitability. And this was based off of a lot of peer-reviewed papers. So that the Center for Limnology gathered a bunch of kind of outside resources and then kind of came up with this suitability model based off of other scientific research. So this equation here is what they came up with, and they were looking at conductivity and how that related to calcium. And calcium has been shown to be a primary factor in zebra mussel growth and how they can survive in their environment. And conductivity is an indirect way to measure that. Since conductivity kind of measures the ions floating around the water, calcium should be one of those, and it should be related. And they gave us some categories here. So there's not suitable, borderline suitable, and suitable. And the conductivity measurements that you get on the lake, you plug it into the equation, and it should give you an estimate of where your lake falls on one of these categories. So we took conductivity measurements while we were out there, plugged it into the equation in Excel, and also went to a lab and got an actual calcium measurement from there. We'll get more into that. So how were the water samples collected? It's very simple. It was a 6-foot integrated pole sampler. This is used in long-term trend sampling and citizens lake monitoring sampling. And this was advised to be used by, I believe it was Katie Hine and Pamela Toshner, since this was kind of an interesting project. We weren't really sure how we should do it. And this is the protocol that the DNR had recommended. So the samples are taken at the deep hole, just like most water samples are. And we took the conductivity with that sample from the pole sampler and then put a portion of that into a bottle for the state lab. And an important note is that these lab samples are fixed with nitric acid, and it's essentially a preservative just to keep the metals at the same concentration they are in the field as to when they get to the lab. The nice thing about these samples is they don't need to be cold. And so if you don't get all your sampling done at the same time, it's okay. There's a pretty decently long shelf life before they need to get to the lab. So we did use the state Lab Hygiene, and this is usually the best option when you have a state DNR grant. It just works well this way because they are familiar with swims and they help you get that information into swims when it's completed. And it's also nice to work since they are a part of the state government. It's easier to work with the grant system. The samples are relatively cheap. They're $36. That price can fluctuate from year to year, but very affordable. And it allowed us to do, like we said, 30 lakes with some of the funds we had left in our grant. An example of what the results look like would be on the screenshot here in the bottom right. They give you the results in milligrams per liter, which aligns with the units that was in the Center for Limnology study, which is nice because then you don't have to do a bunch of conversions and just makes it easier to see where your lake or river, whatever you're monitoring, falls within the categories. So what did we find? This screenshot of Excel here might be a little jumbling at first, but what I want to kind of point out is the highlighted categories. So the current predicted suitability that's highlighted there is what is shown on the AIS Smart Prevention tool. The conductivity suitability that's highlighted is using our conductivity that we found out on the lake. So the most current conductivity that's available. And then the actual suitability is what was gathered from the state lab using the true calcium measurement that was in the lake. And what I want to point out is that in the current predicted suitability that's outlined in the Smart Prevention tool, that's using conductivity data that can be 50 to 60 years old. So it's not really too big of a surprise that there are going to be some differences when we use some current conductivity data when we go out on the lakes in present day. And then beyond that, there are some differences using the actual calcium number that we get back from the lab. So there are some inconsistencies here between the tool, current conductivity, and the calcium number. Granted, they're not too far off, but it can be important for some of the lakes that are right on the edge of categories. And we did have lakes that went either up or down in category, but most of them, the calcium was a little bit higher. Overall, the tool is still a good baseline, but it is not perfect. And I hope you can see my cursor here. And what we would like to point out is that calcium was almost always higher than the predicted calcium using the equation. So the calcium that we got when we were out on the lake, so a current I'm sorry, let me start over. The conductivity that we got out on the lake, the current conductivity is what the predicted calcium would be in the blue. And the actual calcium number that the lab gave us would be in the orange here. So the calcium is almost always higher in most of these lakes. And that's important because these lakes that are right on the borderline categories could either go up or down into the unsuitable, or some of them, it pushes them farther into the suitable category. So the lakes that are right on the edge, it's interesting to see where they truly fall. I would point out that some of these lakes that are kind of way up here in Neverland, these are drainage lakes and they have a lot more inputs in the system. So the conductivity measurements probably are not as reliable as these lakes down here, as these are seepage lakes. There's just a lot less, I guess, I don't want to say junk floating around in the water, but there's a lot less for the conductivity measurement to take up. And the Washburn County lakes essentially did the same thing. A lot of the calcium measurements were higher than what the model would predict. And it did push some of these lakes up into the borderline category and just kind of changed how the model would be viewed, I guess you could say. An interesting thing that is on this slide is that Middle Mackenzie, Big Mackenzie, and Lower Mackenzie are currently listed on the Smart Prevention tool having different suitabilities. So Big Mackenzie is listed as suitable, Middle Mackenzie is listed as borderline, and Lower Mackenzie is listed as borderline. And when we took the actual calcium measurements out there and the conductivity measurements, all three lakes essentially have the same water and they're all suitable. So that was another interesting finding, I guess you could say. So our final thoughts, if you're a lake association or anyone else that's interested in finding, I guess if you want to say the true suitability or how the calcium actually is in your lake, it's relatively easy to do so. And if you're interested in it, I would suggest contacting your local lakes biologist with the DNR. Most CLMN coordinators and these lake biologists could have some of the equipment that you might want to use, like 6-foot pole samplers, conductivity meters, things like that. If not, the 6-foot pole integrated sampler is very easy to make. It's essentially just a PVC pipe tube and a couple little pieces of hardware. And the state lab of hygiene, like we had mentioned, the cost is very minimal. It's only $36 and very affordable, at least to many people. And once again, the monitoring that we did showed us that a lot of lakes that are right at the borderline suitable category can either go up or down, generally up, but it's interesting to see where they fall. And no matter what suitability your lake has, additional AIS prevention steps are always strongly encouraged because you simply can never be too safe. A lot of our lakes have decontamination stations here with the Burnett and Washburn County ordinances. And even if their lake still lied in the unsuitable or borderline suitable category, a lot of them are still very gung-ho about keeping their stations out there and wanting to continue that effort. And Lisa, if you had anything else to add, that's essentially all we had.
Nope, I don't have anything.
So with that, we can take any questions or comments. I see there's one question in the kind of chat here. Someone was asking what the natural log of calcium means. And essentially, usually when someone uses a natural log equation, it's used for showing the data in trends. It maps easier on a chart, and it's easier to deal with large quantities of data.
My apologies. I was on mute. I just read that question to no one. Thank you for fielding it, Tom. I appreciate
Yeah.
it. Yeah, thanks for the math question. Those equations can get kind of funny sometimes. I like the idea of indicated calcium anyways, but thanks for the explanation. Natural logs. If anybody has any other questions, I'd encourage you to type them into the Q&A to the right of the video window. I have a couple of questions if that's okay. It's interesting work. So it seems like the smart prevention model is over optimistic. Do you want to speculate at all why you think that might be?
I don't want to get too deep into the weeds on that, but I think a lot of it has to do with just the age of the data, simply because the data is 50 to 60 years old and things have changed since then. There's more development on lakes, more inputs in the system. I'm not quite sure. I don't know why it would underestimate the calcium in the lake. I would prefer that it would go the other way so that people would say, they'd be a little bit more cautious that way, but it is what it is. And it's still a pretty good tool. And I still suggest people use it. It's definitely better than nothing.
Yeah. Have you had any communication with the CFL on that piece? If there's, if it's kind of predictably under predicting, if they are interested in sort of using your ground truthing information to revise their equation?
We haven't met with them yet, but I know Lisa and I have talked about that.
Awesome. Yeah, that's neat. It was really a cool opportunity that you guys had to be able to ground truth some of that info. We have another question in chat. How will you be using this data to inform AIS prevention activities, especially with regards to CBCW, Clean Boats, Clean Waters, our boater education and outreach program, and further monitoring?
So we have a very large zebra mussel team here. As Lisa had mentioned, there's a lot of monitoring that goes on between Fish and Wildlife Service, National Park Service, the tribe, us. And a lot of that happens to do with veliger tows and eDNA and a lot of different monitoring pieces, I guess you could say. And this kind of shows us some of the lakes that we should probably be focusing more on. Monitoring is still spread out very evenly across the landscape, but this has allowed us to kind of zero in on some of the lakes that would be more at risk. And we do the same with our Clean Boats, Clean Waters personnel. We have a pressure washer unit that goes out with our people and travels around throughout the counties. It's a shared unit, and that will be going to some of these lakes that are more at risk as well.
Calcium is another question from the chat. Calcium is one important component of suitability, but food availability and substrate are also really important. Does the SMART prevention tool only use calcium for assessing suitability?
Yes, to my knowledge, the SMART prevention tool only uses calcium in the finding which lakes fall into each category. The reason for that is because it was the largest data set available to the researchers at that time, since the surface water inventory was basically done throughout all of Wisconsin. They were able to have a large data set to work with, and since conductivity was there, that's what they used. It would be much more difficult, I would imagine, to incorporate, rock and sand or muck substrate and other factors into an equation rather than a calcium number.
And it is interesting too. So of course, the big and middle have the zebra mussels, but we've been doing a lot of monitoring on the 3 lakes, and we still have not found anything positive in Lower Mackenzie, even though their suitability is pretty well. Lower and big have the same suitability, so it's interesting.
And they are connected by stream. So they haven't gone downstream to Lower Mackenzie. It's a little bit farther of a stretch. So hopefully they never get there. I would like to point out though that when we've done some aquatic plant surveys out on Big and Middle Mackenzie, and the whole substrate concept has definitely changed in my mind. When we have done point intercept surveys out there, almost every plant that we pull up has zebra mussels on it. So when you think of rock and gravel and hard substrates like that, a lot of times they'll attach to whatever they want to. And if that happens to be northern water milfoil or whatever that plant is, it'll be just full of them. It's pretty incredible. I've even seen dragonfly nymphs out there that have zebra mussels all over them. They're a whole different creature.
That's really interesting. If you've got a lot of plant area colonized, then you're kind of changing the position of all those nutrient cycles in the lake too. We always think about zebra mussels being on the bottom, like benthifying. That's really cool. We have another question about variability in sampling. If calcium content measurements would calcium content measurements change if the sampling is done on a different day or time? Are there numbers you determined fixed for a given lake?
I would imagine that the numbers could fluctuate a little bit, although I think generally they stay relatively stable throughout the year. Correct me if I'm wrong, but I think that they're generally pretty stable. I know conductivity can change a little bit based on water temperature, but we sample that at kind of the later summer half of the year, and we would be more concerned with the open water period anyways, because that's when things could be getting introduced.
Well, great. I think we'll wrap it up for there. Thank you very much, Lisa and Tom, for your presentation.